Today, we're launching LFM2 24B A2B. If you're interested in running large language models on your laptop or PC locally, this is for you. This model is based on the optimized LFM2 architectures for fast on-device inference. It's a mixture of experts architecture that has 24 billion parameters in total, but in each token generation step, only around 2 billion of those are active. The result? On a laptop, we see almost 2x the token generation speed as a Qwen30B3 active. With this model, we scaled our LFM2 foundation model architecture from 350 million parameters of the smallest variant to 24B of this current release model. That's almost a 100x scale that our architecture and model can handle. The size was chosen to really fit onto 32 GB of memory that we have typically on a modern laptop or PC. We support edge inference with the Llama CBP stack that has been recently merged or joined Hugging Face organization, which is a really nice accomplishment of the open source community. But also for hosted inference, we see compelling results where our model sees the overall throughput in terms of the number of requests per second on a single device, in this case a cloud-hosted H100, massively outperforming the competition. So it means really that the cost basis to operate this model at serving the same volume is much lower than competitor models. Let me directly demonstrate how fast this model is when we run it locally. So let's check out LFM2 24B in action on this mini PC that I have here. So if you go into the terminal and run ls cpu, we'll see that the machine has an AMD Ryzen AI 9 HX 370 with an integrated graphics card, Radeon 890M in there. And specifically already downloaded a preview version of the LFM2 24B quantized with 4-bit, as well as with plain standard Llama CBP. And the first thing that we will run is to show you the speed. So we'll use a tool called Llama Bench that is shipped with the standard Llama deployment package. And that one basically runs a test to check the speed of both prompt processing or prefill and also token generation or decode. And one thing that we see here first is that it's using the Volcom backend. So we are actually using kind of the AMD Radeon graphics in the integrated graphics card to actually execute and run this model. So we see already the first results on the prompt processing. We are seeing almost 500 tokens per second. So the prompt gets kind of consumed and processed with like a very fast 500 tokens per second. For the token generation, so for the decode, so when it starts generating, we see that around we will get 50 tokens per second. Note that it still shows LFM2 MOE 8B version, because this is not the released version, but a preview, an internal preview that I'm having access here. And but if you look at the parameters, we see that it's actually the 24 billion parameters that the model has. So instead of Llama Bench, let's use a different binary. It's called the chip with the same download package. It's called Llama Server. Specifically, we'll run again the 24B, and we set also temperature to 0 because usually model performs better with a lower temperature. And we see again, if you scroll up, that it's using the Volcom backend to run and execute this model. Additionally, Llama Server spawns a normal OpenAI chat interface, but also a UI that we can just connect to with our browser. So this is kind of the interface, user interface, using Llama CBP to run our model. And let's ask it a simple prompt. Write a teleprompt text for a video about the launch of LFM2 24B A2B. So it does respond very fast and smoothly, and we see that we get here around 46 tokens per second, so almost the 50 that we saw in the Llama Bench. And yeah, this is a very smooth behavior. It outputs like some teleprompt text. Let's actually make it more about that this model runs on laptops. Again, almost no latency. We see immediately the model starts generating text with very fast. Note that the training of this model has not converged yet, but it's still training and the metrics are still going up. If you're interested, check out the model on Hugging Face. It's open weight. Test it on our Liquid Playground, or check out our Liquid docs on how to run these models locally or fine-tune it.